Hi, I'm Nesta and I'm in the front of the catalyst, and as an engineering design student I was really interested to see and understand how this building actually fits and manages its sustainability credentials. In this episode we're headed up to the roof to have a look at the array of the PV panels and have a look at how solar is harvested and used for the building. So we're currently on the roof of the catalyst building, and as you can see we're surrounded by all these wonderful PV panels, and
I'm Laura Rhodes. I'm Sustainability Engineer within the Estates Department at the University.
And so this building was designed with a focus on reduction in carbon and fossil fuels?
That's right, yes. So there's no gas connection to the building. It's all powered by electricity, and the idea is to meet as much of that electricity demand as possible by this massive array of photovoltaic panels. So
Awesome.
As you can see, they're covering the whole roof. We're facing southeast here, so we've got a lovely sunny day today. So hopefully capturing a lot of energy. These panels have a semiconducting material within them which gets energised by the sun and produces electricity. That's direct current electricity that then goes to the inverters, which are over here, and that converts them to alternating current electricity.
Yeah, usable. Okay, that's absolutely awesome. And so I know that these ones are specifically for generating electricity, and that the rest of the energy is sort of maintained and insulated by the building, is that correct?
So the idea is to reduce energy demand as much as possible by a combination of passive techniques. So as you say, a lot of insulation, the building is very airtight, so we're minimising the heat losses from the building, maximising solar gains, not just by these PV panels but within the building. We want to maximise solar gains in the winter time by that low sun, while preventing overheating in the summertime.
Yeah.
And then the energy demand of the building, we have air source heat pumps are delivering heat, so they're very efficient. They have an efficiency of 3 times gas boilers.
Okay.
So they're using very little electricity to reduce the heat demand of the building.
Awesome, ace. And so I'm assuming that in the summer we'll get a lot of surplus energy and that can be sent back to the grid, and then in the winter and around less forgiving seasonal times, I assume it'll be more
That's right, yeah.
Standard.
We just hope for a lot of lovely sunny days like this in the winter time. In the future we might look towards battery storage, so all these technologies are emerging, so there's potential for that in the future to store the energy that we're not using at the time for
Awesome.
Yeah.
So if certain parts of the building are empty, how do we ensure that them parts aren't using energy and wasting it?
So if we have electricity being produced by these PV panels that isn't needed by the building, it would actually go into our electrical grid system within the university to be used elsewhere on campus. Back about 5-10 years ago, it was very popular to export surplus electricity back into the grid. With changes to the national grid, obviously the grid is decarbonising. There are a lot of micro renewables that are going into the grid. Things are a bit different now, and it's usually better to try and use the electricity as much as you can rather than export it.
Yeah. You would think the logistics surrounding it aren't very forgiving anyway, and it wouldn't really be worth it by the time.
Try and use it.
Yeah. I hope you found that really interesting as much as I did, and I hope you join me on the next episode to find out more about this wonderful building.